So now we will start with question number 86. And this question is asked in engineering service exam 2022. Okay, ESE 2022. So this question is which one of the following is the method of wet mechanical analysis of a fine grained material? Actually, we have already discussed this question in previous video. So the answer is uh, D. And uh, we have already explained this question. Okay, so now question number 87. Question number 87. Question number 87. Question number 87 is uh, one dried soil having a mass of 200 gram is placed in a picnometer, which is which is then completely filled with water. The total mass of the picnometer with water and the soil inside is uh, 1605 gram, 1605 gram. The picnometer filled with water alone has a mass of 1480 gram. What is the specific gravity of soil? Okay, so in this case, you know that if this is a picnometer, if this is a picnometer, mm, if this is a picnometer, okay, okay, this is picnometer, and the weight of picnometer, that's only picnometer, nothing inside it, empty picnometer, and the weight is W1. Weight is W1. Okay, and weight with dry soil. If this is soil, this is soil, then weight with dry soil and picnometer is W2. Okay, and if we fill this with water, this is soil, and if we fill with water, okay, let me take it, it's blue. I'm filling this with water also. So the weight is W3. And if fill with the picnometer only with water, and the weight is W4. Then the specific gravity is given at GS is equal to W2 minus W1 divided by W2 minus W1 minus W3 minus W4. Okay. And in this question, the weight of solid, oven dried soil having a mass this. So weight of solid, WS is given 200 gram. Okay. The total mass of picnometer with water and soil inside it is this. So this is W3 given. W3 is equal to 1605 gram. The picnometer filled with water alone, the mass is what? So this is W4 is given 1480 gram. So WS, weight of solid, is nothing but W2 minus W1. If we subtract W2 minus W1, then we will have only the weight of soil, the mass of soil. So this is nothing but W2 minus W1. So W2 minus W1 is 200 gram. So this ratio is nothing but 200 gram divided by W2 minus W1 is 200 gram minus W3 minus W4 is 1605 minus 1480. And when you take this ratio, and this is 200 divided by 200 minus 125, this is 200 by 75, and this is 2.666, 2.666, that is 2.67. Okay, so the option C will be the correct answer. Okay, this is all about question number 87. Now question number 88. Question number 88. A soil sample has a porosity of 40%. So porosity is 40%. This is what? 0.4. The specific gravity G is 2.7. So what is void ratio? So what is void ratio? So void ratio is nothing but E is equal to porosity divided by 1 minus porosity is 0.4 divided by 1 minus 0.4 is 4 by 6 is 2 by 3 is 0.667. So option number C will be the answer. Option number 88, option number C. Okay. Now question number 89. Question number 89. Question number 89. Large part of northern India lying north of Wind Satpura range, Vindhya Satpura range in the Indo-Gangetic and Brahmaputra floodplains are covered by so soil that is deposited by running water is alluvial soils. Okay, so the answer will be C. Okay, talus is what is talus? Is gravity deposited soil, and alien soil is air deposited, airborne soil, and colloquial soils are colloquial soils is not related to uh, alluvial soils. Okay, so the answer will be uh, the alluvial soils. Option number C. Okay, it is colloquial soil. Colloquial soil. This is nothing but mm, gravity deposited soil moved by moved by gravity, and it is angular, stays close to source, stays stays close to source. Okay, and the shape is like angular, it's messy and angular. Okay, it is nothing related to the alluvial soil. Okay, alien soil, you know better. Okay, it is deposited by air, and talus is also deposited by gravity soils. Okay, talus is also deposited by gravity. So this is all about this question. So next question is question number 90. Question number 90. Which of the following statement is not correct? Okay, not correct. So the porosity of a rock depends upon size and shape of the rock grains. Yes, it depends. This is correct statement. A specific gravity is useful for calculating the rock overburden stress. Yes, this is also true. The porosity does not depend on rock mechanical processes. No, this statement is wrong statement. The porosity of a spherical rock grain is high in case of cubic packing. Yes, this statement is also correct. So the incorrect statement is C. So answer will be C. Let me explain this in detail. Okay. So about first option, the porosity of rock depends upon size and shape of the rock grain. So porosity is highly influenced by how particle fit together. How particle fit together. Okay. Porosity porosity is highly influenced by highly influenced by how particle fit together. How particle fit together. Okay. Irregular shaped or poorly sorted grains, different sizes, can fit up wide space more effectively than uniform spheres, thereby changing the porosities. Okay, irregular, irregularly shaped, irregularly shaped, or poorly sorted grains, or poorly sorted grains, different size, different size, can fill up wide space, can fill up wide space more effectively, more more effectively than uniform spheres, than uniform spheres, thereby changing the porosity, thereby changing the thereby changing the porosity. Okay, this is option A. Now option B is a specific gravity is useful for calculating the rock overburden stresses. Yes, this is correct. Overburden stresses, over overburden pressure, stress, overburden stress at a depth of at a depth at a at a depth is calculated using the using the using the using the unit weight of the rock of the rock. Since unit weight is directly since since unit weight is directly related to directly related to specific gravity, specific gravity, GS. It is critical parameter. It is critical parameter for determining for determining the pressure exerted by the the weight of the overlying rock. Layers. Now, option number C is the porosity does not depend mechanical on rock mechanical processes. No, this statement is wrong. So A and C, option A and C is exactly opposite. So what is A? The porosity of rock depends upon size and shape of the rock grain, and the C is the porosity does not depend on the rock mechanical processes. No, no, this is not exactly opposite. This is independent option. Okay. So option C is it depends on mechanical processes. Porosity depend. Okay, depends. How it depends? Let's see. Rock mechanical processes. Rock mechanical processes such as compaction, such as compaction, such as compaction due to pressure, due to pressure. Okay, due to pressure, due to pressure, fracture and fracture, fracture and weathering, fracture and weathering, fracture and weathering significantly impact porosity, porosity. Okay. For example, for example, mechanical compaction, mechanical compaction reduces the volume of voids, the volume of voids, volume of voids. Okay. While tectonic stresses, tectonic tectonic stresses tectonic stresses while tectonic stresses can create fracture, can create fracture that increases secondary porosity, that increases secondary porosity. Okay. And the last one is uh, let me take this space. for last option number D. Okay, let me explain about option number D. The option number D is the porosity of spherical rock grains is high in case of cubical packing. Yes, this is true. In a study of packing, in a study of packing, cubic packing, cubic packing is the loosest, is the loosest possible arrangement, loosest possible, loosest possible arrangement for uniform sphere, for uniform spheres, for uniform spheres, resulting in resulting in high porosity, high resulting in high porosity, that is 47.6%, and it corresponds wide ratio as E is equal to 0.91. Very important. 0.91. Okay. And in contrast, rhombohedral in rhombohedral packing, the tightest packing is this. The tightest one. The tightest one packing is rhombohedral packing, results in a much lower porosity, results in a much lower porosity of of about 26%, and it corresponds E is equal to 0.35. You can relate porosity and wide ratio using this formula. I am writing this with another pen. With this formula, uh, E is equal to porosity divided by 1 minus porosity, or porosity is equal to E divided by 1 plus E. Okay, you can relate both these with this relation. Okay, so this is all about uh, question number 90. Okay, so now question number 91. Question number 91. Consider the following statement regarding sedimentation analysis of soil particle based on Stokes law. So in we have seen Stokes law in previous question when we are solving question number we are solving question number 86. In this we have explained Stokes law in very detail. Question number 86. Okay. So based on Stokes law, uh, there are three statements given. We have to choose the correct one. Okay. Which of the above statement are correct. So first statement is the finer soil particles are never perfectly spherical. Yes, this statement is uh, correct. The second statement is all the soil grains may have the same specific gravity. No, this statement is incorrect. The statement is written that all particles may not have same specific gravity, but we assume the average value of specific gravity in Stokes law. Okay, so this statement is wrong. And the third statement is particle constituting to fine soils fraction may carry surface electrical charges. Yes, this is a correct statement. So statement 1 and statement 3 is correct one. So option will be B. Okay. So let me explain in writings. So according to Stokes law, according to Stokes law, the first point is Stokes law assuming Stokes law assumed Stokes law assumed Stokes law assumed all particle to be all particle to be spherical, all particle to be spherical, but finer particle, but finer, finer particles are never perfectly spherical, are never perfectly, never perfectly spherical. The second point is all all particle may not have, may not have, may not have same specific gravity, same specific, may not have same specific gravity, but we assume, but we assume the average value of the average value of specific gravity, average value of specific gravity in Stokes law. Stokes law. And the third is particles are assumed to be settled. Particles particles are assumed to be settled, not settled, settle independently, inde, independently, but but since fine particle have, but since fine particle have surface charge, surface charge, they may join together. They may join together. Okay. So the statement 2 is wrong, 1 and 3 is correct. So option number B will be correct. Question number 91. Now, question number 92. Question number 92. What is meant by thixotropy? What is meant by thixotropy? Porosity of uh, proprietary of material which manifested by its resistance to flow. No, no, this is incorrect. Thixotropy is not this. The ratio of UCS, unconfined compression strength, in the natural or undisturbed state to that in the remolded state. No, this is not thixotropy. Undisturbed to this is sensitivity. Okay, this is not thixotropy. Option C, the compressive stress at failure giving due to allowance to the direction in area of cross section. No, this is also incorrect. Phenomena of strength loss. The phenomena of strength loss, strength gain with no change in volume of water content. Yes, this statement is correct. So option number D is correct statement. So about thixotropy, we already explained in the previous problem what is thixotropy. So I am not going to explain it again. Okay, so option number D is correct. Okay, so now question number 93. Question number 93. This question number 93. When the specific gravity of solids is known, which one of the following types of method is used to determine the water content? This is pycnometer method. 93. Option number A is correct. And this is water content W is equal to W2 minus W1. Actually, W2 minus W1. What is W2 and W? Let me first explain this. W1, what is W1 and W2? Okay, so answer is A. And how we calculate this? Let me explain this. This is W1. This is W2. This is W3. And this is W4. Actually, what is this? Let me write. This is only pycnometer. Okay, the weight of pycnometer W1. Weight of pycnometer with soil is W2, and weight of pycnometer with soil, and when we fill water with this is water, so this is W3, and when we fill pycnometer only with water, this is W4. So the water content is given by W2 minus W1 divided by W3 minus W4, and GS minus 1 by GS minus 1. This is the water content. Okay. So water content is calculated if a specific gravity of soil is known by this formula. Okay. This is all about question number 93. Now question number 94. Now question number 94. Okay. Question number 94. Which one of the following soil are transported by wind? By wind. You know what is this? Is alien soil. 94. Option number C. Okay. So this is all about the chapter 1. Chapter 1, soil mechanics. Chapter 1, soil mechanics. Okay. Chapter 1, soil mechanics. This is all about. Today we finish this with 94 questions. And if you do this 94 question, uh, you will not miss any question in engineering service exam. The question which is asked from chapter 1, that is origin of soil, origin of soil, and soil water relationship. Soil water. This is chapter number 1, soil mechanics. Yeah, the end. Chapter 1 is finished today. Okay, with 94 questions. In these only we have excluded the ESE 2024 paper. Okay. ESE, uh, no, 2024 is included in it. 2024, let me check. 2024 is included. Okay. So this is included. The only excluded is 2025 and 2026, which was held on 8 Feb, 8 Feb, which was held on, which was held on 8 Feb 2026. So these 2 year engineering service examination, um, we have excluded the question of soil mechanics, um, and rest are included. Okay. So this is all about today. Thank you. From tomorrow, we will start next chapter. The next chapter is chapter number 2, uh, classification of soils. Okay. Thank you, everyone.